Yep.
All right, we are live. Welcome back, everybody, to the Baseline Show.
Yes, we have HyperOracle joining us for part 2 this week. They were last on a few weeks ago, actually exactly a month ago, and we've been eagerly waiting to learn more about the work going on. That was this very fun show. It really set the stage for other guests we've had on and just the content that we share on the Baseline Show. And we do hear lots of feedback from surprising groups of people or individuals from companies that I wouldn't expect, or schools or things like that, that tune in and ask specific questions about HyperOracle and the groups that join us. So it is being watched and is very appreciated to have your time today again, Carton, to talk through more of what's going on at HyperOracle and apparently a new thing going on of a world computer that you're going to share with us more about today. But I'll hand over to you to maybe give some context on what we want to cover today or things like that.
Cool. Yeah, hi, nice to see you guys again. And yeah, today I think we're gonna share more detail for like what's our work in zkPOS and what's our work on the world supercomputer. So right now, basically, we are trying to enable Ethereum to be and Bitcoin actually to have like some machine learning ability by putting on like zkML project together and some like application level big model AI, large model AI to work with Ethereum. And we propose a new concept about how to use AIGC NFT on Ethereum and how to do the use Ethereum to send out the inference test. Yeah. So let me jump into it. So first, like, let me introduce like what we learned last time is like the zkPOS. So we know, give me a second, sorry. So we know the zkPOS is a really complicated thing. So we need to have like a really detailed guide to how to engineering this thing out step by step. And one of the challenge is like actually it's like a SSC thing. So basically you have like a dynamic data set before you actually to certain which data you need to, which transaction need to be included in the next block. And it's keep changing like until like you can finalize it, you don't know which data set you need to prove. So you need a new kind of data structure to put down this data together. So because this data are updating every moment, like every second. So you need how to choose the data structure that is updatable, and it will be one of challenge to make the zkPOS thing. So zkPOS, the reason why zkPOS is so important is because like it's the first step to do any operation decentralizedly on Ethereum. So back to the topic, like the world supercomputer we are working on. The world supercomputer basically is like we have a website host on, and also we are about to have a lot of events on Mount Agro with AdCon, and you talk more detail about this idea. So it's more like a grand overview for what we are going to do in the future. What's our ultimate goal? We want to enable Ethereum as like a decentralized machine learning inference platform. It's kind of like that. So that like anybody can host any model to do the interaction with another model. And the basic idea for that is like right now, if you have a classical blockchain, if one node want to verify another node's information, a computation result, like or signature and whatever, so you need to replicate the whole computation process, you will need to like redo what they do to verify if they are computed correctly. But obviously, it's impossible to scale if you want to do the machine learning inference on it. Because like not everybody data will be able to have enough hardware to replicate the whole computation process, or it's gonna be super slow. And but in classical blockchain design, you need to let another node to fully replicate the process. And the basic idea to enhance the computation ability for a fully decentralized blockchain is that you can have like one super node that is like doing the whole computation, and then you generate the zero-knowledge proof from the execution trace, and then you can submit the trace, the proof of the trace, and the computation result back to the blockchain. That's basically what like ZK automation does. So ZK automation basically is like doing ZK automation. Then ZK automation is basically doing so basically ZK automation is like doing this thing, like you take on-chain data and then do the off-chain computation and put the result with the zero-knowledge proof back to the smart contract. But the difference is that the ZK automation, they normally take really simple condition. The condition for automation trigger normally is like kind of simple. It's like A variable is smaller than B variable, plus B variable is like smaller than C variable, something like that. And then the automation job will trigger and then submit the program and do the computation result, submit the result of the computation to the smart contract. And but for the world supercomputer level, it will require another level of computation, and normally we use like linear regression as a standard to identify if a computation belong to ZK automation or belong to ZK ML. And so back to the world supercomputer, if you want to do a really complicated computation, like linear regression, like more than linear regression will be like some sort of like AI inference for generate an image or generate a video or generate a music. So as we know, like AI generation content will dominate the field really soon, probably in 2 to 3 years from now. And but so we need to like have like a new kind of like a blockchain vision on how to adapt, embrace the AIGC with like on Ethereum. And so our plan is that, so right now, why Ethereum really hard to, not just Ethereum, any like classical blockchain, really hard to do anything related with AI is limited by is because like it limited by its computation ability and the how it is really expensive for the storage. And so how we resolve this problem, the first one is like we put like the computation off chain, but we need to want to keep it decentralized. So that will means like you just need a group of cluster to do the computation, but you need this group of cluster to convince all the rest of the validator and node or miner on the classical blockchain to trust the result, and everybody will be able to submit the result. So once if this cluster is not working, and we can it's like a minor competition, you can just use another cluster to do that. And and then because like the cluster itself will generate the proof for the inference, so all the node will not need to have like super beefy machine to verify it, because like the point to use zero-knowledge proof is that the verifier is like a super slow machine and with really limit memory and computation ability. And so this solution basically architecture will resolve the computation part. And we have also another kind of native rollup, we call it native rollup solution. It's like ETH storage to resolve the IO part. Basically, like for machine learning model, you have require a way bigger input and a way bigger output. So right now, one Ethereum contract, the limit is like 24 kilobyte to have like the size for a smart contract. to storage the data, and then you cannot do more than that. And it will, but as we know, the output for a machine learning model normally really big, and definitely way more than 24 kilobyte. And so we will need like extension for the storage too. So the basic idea is that traditional P2P network, not just all P2P network actually, will have like trilemma. So in blockchain trilemma, it's different with blockchain trilemma. The blockchain trilemma is like more like decentralization, between decentralization and security and scalability. Yeah, basically something like that. But what if you view the blockchain as like world computer, it will have like world computer trilemma, which will be like a P2P network will be able to good at like either consensus or computation or storage. Because like I take one really simple example. So because like strong consensus means like you have a lot of Turing machine is running certain same program and storage same data. So which means like one computation task will be need to propagate inside a network, P2P network, and then you need to propagate between amount of P2P network, and then you will need to issue this job to all the node to do it, and it will take like time because the light speed is limit, right? It's a constant, and then so because also plus the internet latency, so it will take times to issue this job, distributed this computation job into the network. The stronger consensus means that you have a way more node in the network, and then it will take longer time to propagate this job, distributed this job into every node. And then plus you need like at least 30% of the node to finish the computation, and then they can agree, put down the signature on it, like in POS. And then you will also need to storage same piece of data in all of the node. For instance, if like storage one piece of data on the computer, it costs like 10 cents. If storage like 10,000 copy in a blockchain, that will cost like $1,000 per data, right? It will be very expensive for the storage either. And so we will like require you have like another topologically different P2P network to do the extension for the computation and storage. It's pretty much like how the computer we have today. So we have like a CPU and memory, right? But like in abstract level, CPU and memory, they are pretty much a same thing, and they are circuit, obviously. And so the difference between CPU and memory is that like in a circuit, the more transistor means like the more computation ability, the more capacitor means like the more storage ability. So in traditional computer, you will need to balance the trade-off between the transistor and capacitor. So how computer resolve this problem bottleneck? So we will like have a one unit that we call CPU that is full of transistor, and then we have another unit that is full of like capacitor, and then we call it memory, and then we use the motherboard as the PCIe to connect them together. So the idea to extend the Ethereum is pretty much similar with this idea. Basically, to resolve the performance bottleneck, you will need to have like 3 kind of different P2P network focus on different thing, and then use like zero knowledge proof as the data bus to connect them together. And then so you can keep the whole network is fully decentralized. And like the reason why Hyper-Oracle network and e-storage network will be able to scale up the computation and storage, the essential reason is because they don't have global status. They don't have a ledger. So which means like if you have a 2 group of like Hyper-Oracle node, and then themselves, between them, they won't have like they won't generate a new ledger beside the one they're using. Is like the ledger they're using is the Ethereum ledger. So because they get up the in topologically, they don't have a common status, the global status. So they don't need to sync up together. So they can just do their job and then submit. The input is from Ethereum, the output is on Ethereum. So they don't need to worry about how to sync up the node. And then the sync up process is happen on Ethereum. So you can understand it is like, so basically the blockchain is like, when we actually implement the blockchain, it's like radically network. It basically it's like you have multiple nodes, and then like you have one information propagate, and all the node around that node will get the information. And then I probably explain this thing. I can explain this thing later. If we can use the whiteboard to draw the concept out, it'll be way easier. And yeah, and then let me introduce all the project that is like working on the world supercomputer thing. And then one is like, the first one is the EZKL. Basically, like this is like a influencer for the machine learning model. So as we know, like the one machine learning model normally have like a huge amount of like parameter, probably like 10 billion, or some of them probably have like 100 billion. Like, I don't know, some model probably is 100 million. But like, as we know, you cannot put even one like 10 billion parameter into a ZKP circuit and generate the proof of that. You're gonna take forever for any computer to generate the proof of that. So what you need to do is like, you need to do aggregation before you put the input into the circuit. So basically, EZKL does this thing, and the front end for Halo 2, that is for machine learning, that is like pretty good library, and it's open source too. And yeah, and then you have like another kind of like circuit like the domain specific language, and we will have some chat protocol like Remainder that's developing by Modulus Lab, and what we are using is Halo 2. And basically, it's like the PSE version Halo 2 that use the KZG commitment. But the problem for the KZG Halo 2 is that like it's not some chat, so which means like you cannot generate the circuit parallelly. And another part is like the ZK bus, data bus. Basically, you have 3 different P2P network, and then you need to have something to connect them to do the data transferring. And because majority of data, the global status for either computation enhancement or storage enhancement, their global status, actually, they're all on consensus layer. So what you need to do is basically use the ZKPOS to sharing this data status. So basically, let all the node, either in storage network or computation network, you'll be able to assess the consensus data decentralizedly. So and also this will make the ZK indexing a way more meaningful, and it's not just for a front end, and also it's for actual heavy computation task. And also we have like a ZKVM session that is like ZK Wasm, and also Valida is like, which is developed by DeLanden and Maxwell. And yeah, and also you need to have a new kind of access protocol. Is 40A04. Like this like new Web3 URL just got approved by Ethereum Foundation, that can be used on like Ethereum client and browser to do a EVM call and access with web page. So this thing is used to replace HTTP, because you got many problems to use HTTP, and if even you want to do a zero-knowledge proof on HTTP, because like majority of websites HTTPS, so the license will be like the buggy point to hack the HTTP protocol if you want to do a proof on that. So you will need another kind of like a bottom layer protocol to replace HTTP to make the whole P2P protocol safer. And yeah, basically that's like basic structure for the world supercomputer. And then like we are onboarding one of application, we call it Move Studio. It's a Move AI thing. This is basically format by 21 stable diffusion plus few transformer, 1 or 2 transformer, to generate a video. And because like right now they are still improving the model, and so we can do a limit demo on a GIF, because like I don't want my bill in my house will be like $10,000 next month. So like we can try out something. Yeah, if like anybody want to propose a prompt, we can try it out to see what video we can make. Yeah, basically it's like what we have. So like, so you can let's do a sample prompt. For instance, yeah, and or we can change the name to either Joe Biden, like push pass, yeah, and you see what we can have. So basically it's like a pixel to pixel AIGC, but it's on for video. And the reason why this thing is pretty innovative is because like it was like kind of impossible to do the inference between the image, and right now they find another way by not using control net. Instead of using control net, they will use like a new kind of like transformer to do the inference between image. And so we want to enable this thing on Ethereum. So obviously the first step is that you want to use Ethereum to do the subscription, and but for the further development, we want to use Ethereum to, yeah, it kind of broken there because data set is kind of small right now. And so this product will launch on Ethereum, and then we want to use Ethereum to issue the inference task to help to reduce the pressure for this project, the pressure for the hardware for this project. Because as we know, the Midjourney, the AIGC for picture, they actually use 90% of their graph card on inference. And so if you can use Ethereum to do the inference test issue out, the pressure for the AI project will be way lighter in the future. So people, any AIGC project, they don't need to worry about do they have enough machine to do the inference. They just need to purchase machine for training. They don't need to purchase machine for inference when people use their product. And also if the first wallet, because like this is pretty much a crypto project, and that is the first wallet that pay to generate this certain image, because like one model with one prompt, we'll be able to only have one output. So you will need to you can because the inference job is issued on Ethereum, so which means like you can index out who pay to generate this this certain video, and then like he will own this video as an NFT on Ethereum. So that's why we call it AIGC NFT standard. And we're still drafting the AIGC NFT standard out, but it will release soon. But I think probably by the end of this week. And yeah, it is pretty much like everything in the world supercomputer thing.
Any questions from the group?
I got one. Since you're working generally on Ethereum or Bitcoin, how are you handling the transaction costs, the gas management?
You mean like the verification cost for?
Yeah, any type of gas.
Yeah, so for the computation, right? Because like verification normally is not that expensive. Normally like for Halo 2 it's like 600,000 gave. That's yeah, it's not expensive for verification, because verification is like a constant O1 complexity operation. So yeah, it's like how Zcash handle it is like how this thing handle it. And yeah.
Well,
and then
my question would be like in an enterprise setting, or just someone using this in a commercial type setting, to where you would have a CFO saying, I don't know if I'm allowed to. I know I don't want to hold crypto on my books. I want someone to manage my transactions for them. I want them to bill me for the service in fiat currency, and I want to pay them in fiat currency. that's one of the things that I kind of see emerging as a lot of these Ethereum based solutions start to really kind of advance. Is okay, how are we gonna how are we managing the transaction flow, because that is going to be something that you're going to need to address, you know.
Yeah, I don't think that will be the product to resolve this problem. So the word supercomputer is more for like enable some machine learning ability on Ethereum. Like, so basically, if you have like really nice model, but there's still a lot of engineering and scientific work here need to be done, and it's not being done yet. So one of the biggest part is like the how to keep the privacy for the model owner. So like obviously, if you do the model is really expensive to train, so obviously the person who want to give me a second. So the model is really expensive to train. So obviously nobody want to hand their model to another person with freely. So we want to keep the privacy when you send out the model to let another party to do the inference. So that will require some NPC technology to resolve this problem. And yeah, basically.
So I do have a question. Apologies. I would like to turn on my video, but it's like there's something completely messed up my camera. And so I need to restart my laptop, but I wanted to get the question in before I do that. So I mean, really, you're not actually validating that the full model transformation was done correctly, because you have, as you correctly pointed out, way too many parameters.
Yeah. So your question is like how to make sure the model is like
how can you ensure that the model is the model that you're claiming you're running, right? So number one. Number two is like how do you know that the model is actually performing correctly based on the claim that it is that model? So it's like there's basically a benchmark. And then third is when you're actually then applying the model to an input, right? Or a stimulus, then the output, how do you prove that that is then actually the correct output, right? Because that's really those are the three key things that you need to prove at the same time. And that is really and that is because you need to have someone attest to the fact that this model is actually doing what it's doing, because there is no way that you can that there is a root of trust that you need to trust that where this is coming from. Otherwise, there's no, you cannot prove it from first principles, right?
So it's true. You cannot fully prove everything inside the model. So what we can do is like you aggregate the model. So as you know, like a machine learning model have a 3 cycle. First one is the training, and then the first life cycle is the training. So you need to have the model train out, right? And then the second is when people use it every time, because like theoretically you have like infinity prompt. So you will need to do like, and it costs a lot of computational resource to inference the result from the prompt with that model. But we know for certain C, if you certain the C for the model, like one prompt, we only have like one output. And then the last part is the verification. And then you want to do the verification to see if this outcome is from this model. And for this 3 part, like we can only handle the inference and the verification. And to answer your question, how we identify if this computation is from this certain model, there's like a lot of way to do it. Like some people use like you can generate a recursive proof or layer by layer in the neural network, and then or you can have like some hash you can basically hash the whole model, the architecture and the parameter. So if like you separate the model in two parts, it's like one is like what's the architecture for the model, and then you can do that as one of the computation commitment for the zero knowledge proof. And then you can also with this method you will also need to use the parameter, which is like about billions level parameter, to as another input for the proof generation. So with these two parts, you will be able to have like verifier on Ethereum that have this computation commitment to do the verification for the inference.
Yeah, so it's
kind of clear more, right? Like, yeah,
yeah,
I know it's still a lot,
you need some form of accumulator, right? You need some form of cryptographic accumulator that you're adding these things to, and then you're proving that this set is part, or this parameter, these key parameters are part of the set, right? So you're wrapping a snark around the accumulator proof. So
kind of like that. It's actually it's like many approach is one of it, and then
but I mean, if you need to constantly update it, right, then
oh yeah, it's pretty hard to do that. It's like you constantly update that, like
so the only way to do that is using accumulators with versioning, right? So you're basically packing proofs inside of an accumulator that you're then proving that it was there. So it gets really complex really fast. So I think the using ZK on like the generative AI side is at least for the foreseeable future, it's going to be a fool's errand. I think what's much more powerful are straightforward computations, small computations that are critical, right? That actually have high value, right? And so more of a ZKVM approach, because I really need to know whether you generated that report correctly, right? And that trusted entities attested to the fact that the input data was correct. So I have recourse, right? So because at one point you need to establish a root of trust that is publicly visible, right? that you're not
but the aggregation process is not happen like in a centralized server. The aggregation itself can done by anybody. So like
yeah, of course. But the key point is, if you're thinking of more of like a trustless zero knowledge internet, right? Is I need to be able to verify that, or if you present something to me, right? I need to be able to verify that not only that I can authenticate you, right? And then I can authorize you, right? That's the zero trust part, which we need. This is mandated. But then you also need to prove to me that whatever data the payload you're sending me, right, is actually what you claim it is, and that it was derived, right, correctly, right?
So we can narrow down the computation into like computation graph, compute graph. So like compute graph normally is like just like the topology for the model. And so right now I have like a model A, and then I use the model A to generate a video with the prompt that is like someone is dancing. And so basically like the whole design for the world supercomputer, you will basically issue this job on Ethereum, say, hey, I want to this model to do an inference called someone is dancing, and then the miner or the prover will execute it. The prover with like ZKML ability obviously will execute it, and then do the inference in that model. And then now that he have the video of somebody dancing, right? And then like, but doing the inference, you will have a lot of inference trace. And that's like idea of ZKVM is the same thing. And then you will need to take the trace and generate the proof, recursive proof between the trace. And and finally you have a set of one proof and then one video. And then now you can use the verifier that is for this model on Ethereum to do the verification to see if this output is matching with this output, and this video and this proof is in matching with this model and this prompt on Ethereum. So that will make NFT collection. Basically, like traditionally, NFT collection is arbitrary. So like a certain human, you define this field image is like a collection of NFT, right? But in the AIGC era, it will change to like this model is as a collection. And then like, because one prompt only have one outcome, right? Obviously. So you'll be able to verify the video with that prompt, with that zero knowledge proof. So I think for your question is that what if if I understand it correctly, so your question is that like it will be not practical if the parameter is keep updating, right? And then you need somebody to do the aggregation and something like that, right?
Right, because generative AI models are continuously updating, right? So it's like because I'm constantly training, right? So I'm constantly training, publishing a new incremental model. So everything changes, right? I might actually add additional model parameters. So it's like right. So
I know what you're saying. Yeah.
Right.
And,
so what I'm saying is like this is until we're getting to much better and faster prover systems, right? That can handle, you know, a larger and a variable set of parameters efficiently. The utility is more around can you verify that things that other human beings or other machines can correctly interpret and understand, whether did you create that correctly. So it's more of you tell me, as you correctly said, what is your computational topography, right? So what is the interference, which different computations did you put together, right, in order to get to the output. And then you're basically have each component is you generate the proof, and then you recursively package everything together, and that is proven. But again, everybody needs to agree what you're actually proving, right? So you're because
I know what you're saying.
And the public data needs to be verifiable, right? The public data that you're sharing needs to be for the public input to the proof needs to be externally.
Yeah, how to respond the parameter changing thing, like is a two approach. Like first one is like do nothing on it. So basically like you certain one set of parameter and then don't change that, because like in large scale model, is the dynamic changing parameter is just for centralized server to try to improve that. But theoretically, the performance for a model have a limitation. And then once you reach that limitation, it doesn't really matter if you change parameter or not. By when user use it, you want to train them more better. But like in majority of machine learning model, you face like the degradation and something like that to limit the performance enhancement by have more data in. And so which means like if you have a sophisticated model, you don't really need to change the parameter constantly. And that's the first one. You don't do anything. You just certain a set of parameter for that certain model. Because like, if you consider a dynamic model, it will be like pretty hard to aggregate the parameter. And then the second one is that you have like the public input is basically is the topology for that certain model. For instance, if you have a transformer, if you don't consider the parameter, I want to claim this output is from this certain transformer, and then you can still prove that, because like what you actually have is like the transformer plus the parameter, like, and then but you can still prove that the outcome, the output is related with the transformer architecture. And then basically it's like two solutions mainly. and but we are only doing the first one right now. And then the idea for world supercomputer is more like how to like extend the computation ability for blockchain with zero knowledge proof. And so traditionally you need to replicate the whole computation process, but now you don't have to, especially for the more complicated computation. You will be able to have like cheaper way, like a way faster and cheaper way to convince all the validator in a consensus layer to believe that you did computation and then computation is like correct. So yeah, it's not for any thing that is like gonna change the industry completely immediately. It's more like a direction for us to work on.
Yeah, no, I completely agree. And also one has to be very, cautious in using a chain because most of the stuff is going to be off chain anyway, and it's going to be a limited number of people that need to trust something. So there's very, very little, I believe, that needs to be on chain, because you're not because you're typically not in a fully permissionless setting, right? The number of permissionless settings is significantly lower than the number of permission settings that you'll encounter, right?
Yeah.
Permissioned in terms of you're actually, let me put it this way, the number of trust assumptions you're making, right? Where you're in a permissionless setting, you're making no trust assumptions, is that is a subset of the practical trust assumptions that you'll make in different business settings, right? You're primarily using zero knowledge proof techniques in business settings for compliance reasons, right? And for because you don't want to violate data privacy, you don't want to share secrets, but the other party needs to be able to prove things.
You are not
authorities, right? So it's like, it's not as if if those are unknown counterparties. Those are always known counterparties, right?
Yeah.
You just need to be able to, you basically need to establish a throat to choke, right? At one point. So the regulators is like, I don't really care, right? As long as I can identify the entity, I can basically rip to shreds. That's fine.
Yeah.
Right?
I think like I think when you talk about regulation, there will be like too many controversial stuff, right? Like, and
no, it's critical if you're because it's like, look, it's like you're not going to be compliant, right? We'll see each other at Rikers Island. Right? I mean, there's like no two ways about it. Like, the Europeans just introduced MiCA, the EU Data Protection Act, the EU Cyber Resiliency Act is also coming out, and they are working that's going through the EU Parliament, and they have no idea how to handle open source.
Yeah.
So potentially every single developer contributor to an open source project is going to be liable, just like anybody who's participant in a DAO. If the DAO is not legally registered, then the assumption is going to be it's a general partnership, which means every DAO participant is as liable as everybody else. So any identified DAO participant is therefore is then directly I mean, all are liable, but they're going to come to you if you're the only one they can identify. They'll come to you for all.
Yeah, I think that's
liability,
fine.
Right?
Yeah, I think that's the reason why, like, after you talk about this, right? It's like that's why we need crypto for AI, like, because like innovation is like the first requirement for innovation is the freedom to do the innovation. So like the original crypto spirit is like punk. That's why I think And,
Yeah, it's like here's the secret. Everybody is going to let you do whatever you want to do until you threaten the established power structures, and then they either buy you out or they're going to take you around the corner and put a bullet in your brain. Those are the two outcomes.
Well, so really simple example here is that China tried to ban the Bitcoin in 2019 when like majority computation ability are in China. But it doesn't work out. Like even China is like really powerful government, but still it's not work out. Like still a lot of people are secretly mining Bitcoin in China. And same thing in America, like even like you can put down a law say this is illegal. This program, Tornado Cash, is illegal. And still like everybody can still use Tornado Cash and nobody can shut it down. Like you won't have like FBI warning, right? Like by using Tornado Cash. And also like even you say
no, but they will the FBI, if you use Tornado Cash and you're stupid, the FBI will come after you.
Yeah, but like
it's not that you can't stop it, but they will come after you if the money is
yeah, I mean like
is large enough.
If like you keep yourself as a professional hacker and keep it anonymous and nobody can actually chase you down. And
yeah, but how many people can do that, right? If you really want this to be usable for billions of people, you must assume that they're just not sophisticated. So you need to make it in such a way that everybody can use it. So it's much easier to work with and educate regulators than fight them, right? Because in the end you'll lose.
Yeah, right now we are talking about the possibility instead of like legal problems. It's like the legal problem will be like, first it will be like really late term thing when this thing is big enough to affect the real world power structure. But right now it's still too early for that. Right now we are still in a way to like how to make it, right? Like it's like when Nakamoto is discussing with Daiwei about how to make the Bitcoin, and like we need to have like a new P2P architecture for have something that is unchangeable ledger, something like that. And then like but we don't need to worry about once we have this new type of money, what's like how US government or like some authority gonna handle us, right? Like so we need to provide this product first and see how this thing goes. And the second thing is like we don't need to worry about too many regulation, because like for the creator itself, although for us we provide the network, right? But it's just like we tell it provide Ethereum, and then like people doing money laundering on Ethereum, it's not his liability to take care of this thing, obviously, because it's permissionless and unstoppable network. Once you deploy a program, nobody can stop it on Ethereum, including
right.
And so do American government or China government or whatever government. And like it doesn't matter, like because this is the freedom. You do it, and then you deploy the program, deploy the model, and nobody can stop it. That's the spirit for crypto. As long as you pay for it and this thing making money, it's like profitable. Like everybody's doing it. And the regulation thing is like a minor thing after you do it, right? And for us, we just focus on the technology itself, like how to make this thing like more decentralized, more unstoppable, and can support more computation graph. Like essentially, machine learning model is one kind of computation graph, and you write a simple automation job. It's like computation graph. They are the same thing pretty much, essentially. Because like, but the difference is that I normally put down a name because like not that many people have think about it. So like I normally put down a name for code. I call it nonlinear code. So like traditional automation code is like you put down A equal to B and then do the rest of the computation, A plus B, and then B trigger contract to do what execution, right? It's like linear execution order. But for machine learning, it's kind of like not like linear. So
correct.
You provide like a nonlinear code ability for the blockchain, and you once deploy the program, like nobody can shut it down. But also this program is not just really simple program. It's more like It's from like if you see the AI as a new kind of life structure, like you see it's like from a single cell behavior to a multi-cell behavior. It's like really complicated. And then we provide a free cyberspace for this model to interact with each other and competing with each other. So that is the purpose for the world supercomputer.
Yeah, no, I don't get me wrong. It's like I think these are all very important primitives that we need to continue to develop and drive further. I'm just telling you, again, I was like the type of discussion.
I see your concern. Yeah.
You know, no, it's not a concern. My concern is that if we are not considering the consequences and how this fits in, the danger of this being effectively then shut down, even though it's really important, is the significant, right? So the you know, thinking about how do we ensure data privacy, right? In this model building, how do we prove that consent was given that for data to be used? How do we prove that we're using debiased data sets for training? And you know, these type of things are they're fundamental questions when it comes to AI. I'm not talking about financial regulation, right?
Yeah.
That's a separate, that's when once you monetize it, right? But just from a data privacy and from an ethics point of view, it becomes really important if you're marrying privacy with these very fundamental AI questions about biasing and things like that, because enterprises are using these models, right? So one concrete example, right? Most health insurance claims are being now adjudicated by machine learning algorithms without a human being ever looking at them, right?
Yeah.
So how do you know that these models are non-biased, right? So there are very important ethical and legal questions that are coming up where this type of technology can help. But we need to recognize that, in my opinion, and build things from the ground up in a way that takes into account these questions, including, you know, as much as we don't like it, regulatory frameworks, because we don't want this to be shut down. We don't want this to be outlawed. We don't want this to be maligned by people who might see that they would have a commercial advantage by disparaging this type of technology. And education, especially education of regulators, is critical for this work to continue and this innovation to continue, because human beings have the tendency to shut things down if they perceive a threat, right? If a threat is to be eliminated right away, whether you understand the threat or not. If you perceive it as a threat, you want to avoid that threat. You want to shut down that threat. You want to eliminate that threat.
So yeah, I mean, this is a huge topic, and it's not gonna be resolved by us, obviously. It's like more like a social ethical debate. But like for us, like we only focus on the technology itself and how to enable Ethereum on machine learning. And I feel like to resolve a privacy problem, right? Like I don't know, is it a threat or not? It's just like a new kind of tooling for engineer. AI is like new kind of tooling, and it's just like when people invent the car, like vehicle, some people worry about this thing drive too fast and they will hit people, right? And then like it will kill people by having a car, allow another person to have a car. And but obviously it's just become part of our social norm today. And once we make something is fully decentralized, like as long as you actually have demand for that, like I don't think this thing is shut downable. Like even though like all the government in the world is like Bitcoin is illegal, and like you still cannot shut down Bitcoin. It just like you cannot use the old governance architecture to govern something is completely revolutionary. And to resolve the privacy problem. One of the solution in my mind is that it's like you use model to train a model. Like, yeah, that will be like a way to dodge the human privacy problem. But for us, like, it's not the problem. It's not our people can concern. Like, it's more like the governor and some top level scientists need to think about. But for us, we just thinking about how to let blockchain have a little bit more computation ability and storage ability that is cheaper and faster, and we'll be able to catch up with the machine learning progress we have today.
Yeah, it's like building, it's like any tooling that you have. Yeah, I do not disagree with you. What I'm merely pointing out is that extending that point of view, right? So a gun that has biometric locks, right? Both for your fingerprint and for your iris, in the end, it's still a gun. And is used for a very specific thing, and that is regulated. And again, thinking about making things better always involves on what are the consequences. Just saying I throw this out in the world, right? It's like the car, your example, the car, right, started in the 1880s, right? 30 years later, right, we had tanks rolling across the battlefields of World War I.
Yeah, kind of. It's gonna be there if it's there, right?
Right. So everything is dual use. So one has to be very careful and conscious what is being done, and make sure that what you develop is developed in an ethical way, and you're stating that upfront, because right now the assumption is that everything that comes out of the Web3 space is basically a Ponzi scheme. You're just that's the perception. So it's incumbent upon us to change that perception by being a lot more thoughtful, and being being a lot more receptive to the feedback that we're receiving from the outside world.
Right. Agree with you. Like, we need to make impression for crypto is better beside Ponzi scheme. Like, one of the reasons is that it's like the usage is crypto is limited beside transaction. Right now you don't see any, like, for instance, if we have like a crypto TikTok, like actually they will produce value for the society, and then or like crypto version YouTube that is like AIGC and something whatever, and then if you can combine this thing together, like you actually provide the production activity on crypto. And I think, like, but for human to use crypto to do the production is like low efficient, because you need to have a gap between the reality and the cyberspace. And but for AI model to do the production on crypto is actually pretty easy, and it's actually really native for the computation program to interact with another program. And so that's why I think, like, if we can enable AIGC application on crypto, on Ethereum, it will bring all the crypto to another level that have actual usage, and and actually have people using it to do something, or like spend their time on crypto. And that's basically what I want to do, like have more traffic.
I agree with you.
And then
I agree with you.
Scam people by like 10% APR or 40% APR, something like that. That would be some boring. It's not gonna be continuable. But like, I think crypto gaming and crypto AIGC will be like the right direction for the industry to have actual traffic, and beside the Ponzi scheme.
I agree. I'm not disagreeing here. I'm just pointing out that there are actually additional primitives.
Yeah.
There are additional primitives also from other technologies that need to be incorporated, such as verifiable credentials that can be proven in zero knowledge, in order to establish the root of trust and traceable trust across across these things. So my challenge to you is to actually we need more primitives to be able to do this in a compliant and ethical way.
I understand what you say. It's just like, it's just not the top priority for me to consider it right now. It's just
I'm not saying it should be. I'm just merely pointing it out that
no, it would be a problem.
This is going to come. This is coming, and this is coming down the pike pretty fast, based on discussions that I have with regulators. This is a lot of stuff is coming down the pike pretty fast.
Yeah, I also think like AI will face like higher pressure on the regulation too than crypto actually.
Will come very quickly. I 100% agree with you. But I think we're past the hour, right? So
right.
Time flies when you have fun, right?
Yeah. Pretty constructive conversation.
Yeah, well, thanks for joining us for part 2. Nothing should stop us from a part 3, and you're always welcome to join our weekly streams and engage in the conversations. But thanks for sharing.
Stuff.
Yeah.
This is awesome stuff, guys. Awesome.
Yeah.
Thank you.
Nice to see you guys again.
You too. We'll be in touch.
Likewise.
Cheers. Bye.
Thank you.
Thank you, everybody.
See you guys.